Good morning, students. Today we are discussing about atomic spectra and the hydrogen spectra. Okay, wow. So next you see that the material in the solid, liquid and gases straight emit electromagnetic radiation. When they are heated up and this emitted the radiation usually belong to the continuous spectrum. Okay, now you see that for example, when white light is examined through a spectrometer, electromagnetic radiation of the all wavelength are observed within the continuous spectrum. Okay, so next you see that in the early 20th century, the many scientists spent the considerable time in the understanding the characteristic radiation emitted by the atoms of an individual element exposed to their flame or electrical discharges. Okay, what is means atomic spectra. So that last year the experiment, the spectroscopy, right? You are doing to the spectroscopy, no? So that some of the white light pass through the prism. The prism, what happens? White lights is passing through the prism. That time what happened? The electromagnetic electromagnetic radiation is emitted. That electromagnetic waves is produced to the more than spectrums, that is color rays. Okay, so that's we are discuss about here how to that. You see that first we are taking to the one discharge tube. That discharge tube we have to fill to the hydrogen gas, and we have to apply to the some of the light or heat. After you see that heat, you are taking this discharge tube, you are taking to the some of the gas. After you have to heat this gas. Okay, what happened? This gas inside having to the thermal process. So what happens? Leave it out to the some of the radiation. Okay, electromagnetic radiation. So leave it out the electromagnetic radiation. That radiations is through to hit in the gratings. Okay, hit in the gratings. The grating is here produced to the Vibgyor's colors. It's produced to the Vibgyor's rays. This is a spectrum of an atom. Are you understood? So what I am said means, any one atom you are taking, that atom, any one atom you are taking, and it's atoms behind. You see that some of the light hit to the atom. Some of the rays of the light or incident of the light hit to the atom. What they are doing means, it's immediately leave it out to the some of the electrons. How to means, it's a lower level to the higher levels. You see that I will draw to that one. You see that you consider this one's atom. Okay, you consider this one. This one is here atom. So here light, the source of the light. The source of the light, it's here. The source of the lights to travel and hit to the atoms. This is what atom. This is what atom. Okay, hit to the atom. So the atom revolve around to the electrons and protons. Electron and protons. You are understood? Electrons and protons. What happened? The light rays, the source of the light rays hit in the atom. The atom revolve around to the sum of the proton and the electron. The proton is emitted to the electron. So in the positive and the negatives they are having. Okay, electron and proton having. The proton what doing? The proton leave it out that pushing that outside, pushing to that electrons. Though all the electron escape to that outside. Okay, all the electrons are escape to the outside. So that is a electromagnetic radiation. Okay, how to this doing means, it is a lower to higher energy. It's a lower to higher energy, or higher to lower energy. Okay, I understood. This is that hydrogen atom. This is to the hydrogen atom. Again I will tell that you see that when the hydrogen gas enclosed in the tube is heated up, it's emitted to the electromagnetic radiation of the center, certain sharply define the characters of wavelength, that is a line spectrum. It's called the hydrogen emission spectrum. So here as you see that the source of the light rays hit to the atom. The atom revolve around to the electron and proton. The proton what doing means is emit to the electrons. The pushing to outside is pushing to the electron. The electron, all the electrons are escaped to that. Okay, that is electromagnetic radiation. That is we are called to electromagnetic radiation. When any gas heated up, the thermal energy supplied to exit the electron. Similarly, it is the bypassing. So that I explained here. So next, this is the based to we have to you see that the wavelength. Okay, it's emitted to the sum of the wavelength, right? Since you see since electrons are exit the state heavy the small lifetime, this electron jump back to the ground state through the spontaneous emission. Okay, it's a jump to the ground stage. It's a jump to the ground stage. I will explain that ground stage, how to that escape them by emitting the radiation with the same wavelength. So emitting the radiation is a same wavelength only. It's a jump to the ground state level. Okay, wow. So this is called next to that by emitting the radiation with the same wavelength or the frequency, the corresponding the color is observed. This is called the emission spectroscopy. Okay, the wavelength of these lines can be calculated with great precision. Further, the emitted the radiation contain the wavelengths both lesser and greater. So already I told how to it's moving to lower level to higher level or higher level to lower level. So notice that the spectral lines hydrogen the separated the series. Okay, so you see that the series are named as a more than series there. More than series series are named as a Lyman series, Balmer series, Passion series and bracket series, P-Fund series. Okay, this and all. So whenever that emitted to the electromagnetic radiation, it's creating to the more series. So now this class we have to study about to the five series only. One is Lyman series, next one Balmer, next one Passion, next one bracket, final B found. This series only we have to calculate here, how to come that we are study about today. The wavelength of these spectral lines perfectly agree with the equation derived from the Bohr atom model. So how to we are calculate means we are taking to the Bohr atom model, from the Bohr atom model based. Okay, so now we are find out to that formula 1 by lambda equal to R, 1 by n squared minus 1 by m squared equal to V vector. So the V vector is a wave number which is a inversely wavelength. So now that equation you know that 1 by lambda. Now you see that 1 by lambda equal to R, 1 by n squared minus 1 by m squared. So R is a Rydberg constant value. It's R is a capital R is a Rydberg constant value. That value is a 1.09737 into 10 to the power of 7 meter by meter, 1 by meter. Okay, 1 meter by. So next you see that the mn is a positive integration, so number of the value. Okay, so m greater than the n value. So m value greater than n value. Always is a greater in the m. Okay, so next that we have to find out to that various spectral series. First we are taking to the Lyman series. So first we are Bohr atom equation. That equation we are taking 1 by lambda equal to r 1 by n squared minus 1 by m squared. Okay, how to that calculate? You see that this is the atom. This is the atom. The atom revolve around to that more electron. This and all what you know that a shell. This and all the atom, first shell, second cell, third cell, fourth cell, fifth cell and sixth cell. So we are taking to the n equivalent to 1, n equivalent to 2, n equivalent 3, n equivalent 6, n equivalent 5, 3, n equivalent 6. Okay, so this like we are taking. So each one is a shell. Okay, so each one having to the more electrons, each one having to the electron. The Lyman series la what we are doing, the what it is doing means the first cell n equivalent to 1, the n equivalent to 1, it's not emitted to the electrons. The Lyman series la the first cell n equivalent to 1, that cell it's not emitted to the electrons. So second cell it's emitted the electron to the first cell. So third cell emitted to electron to the first cell. So third, fourth also emitted the electron to the first cell. You see that the first cell you go to the second cell. The second cell electron travel to the first cell. So second cell electron pass through the first cell. Third cell electron pass through the first cell. Fourth shell electron travel to the first cell. Fifth cell electron going to the first cell. That electron also moving to the first cell. So the Lyman series, the first cell தவிர்த்து other all the cells electrons moving to the first cell. Okay, second cell, third cell, fourth cell, fifth cell, sixth, whatever the cells, number of the cells, all the cells moving to the electron, all the cells having the electron, that electrons moving to the first cell. That is a Lyman series. So now we are taking to that the first cell, all the electron moving to the, all the shell electrons moving to the first cell. No. So that the first cell we are taking to the n value, n equivalent to 1. Right. So next what about that? The first cell with the other cells 2, 3, 4, 5, 6. That is what m shells, m value. So 2, 3, 4, 5. Okay, this is that. Okay, extend that. Okay, so now we are taking to the value 1 by lambda equivalent to r 1 by n squared. N oda value what we are taking 1. So 1 squared minus m oda value we are taking to any one values. I will take to the 2, first number 2 we are taking. So 2 square, 1 into 1, 2 into 2, 4. So we are taking to the LCM means 3. So here 4 minus 1 divided by 4. So 3 by 4 r. So that Balmer series value is what? 1 by lambda equal to r 3 by 4. Right. So the same like to that doing the Balmer series. Okay, Balmer series. So now you see that first atoms. So first shell n equal to 1. First cell, second cell, third cell, fourth cell, fifth cell. So Balmer series la first cell you leave it. Second cell you take second cell. This is a n equal to 2 we are taking. The second cell, okay, the second cell we are taking. Other all the second cell tavara, other all the cells having to the electrons. Okay, other cells electrons, the second cell tavara, other cells electrons moving to the second cell. Okay, this you see that this is a second cell. Okay, the third cell electron moving to the second cell. Third cell electron moving to the second cell. Fourth cell electron moving to that second cell. Okay, this is the Balmer series. So now we are taking to the n equal to 2. Okay, all the electron moving to the second cell. Okay, so we are taking to the n equal to 2. So then n is always greater than n. M is always greater than m. So what we are taking 3, 4, 5. This cells only the cell's electrons only moving to the cell 2, right? So we are taking to that first one, apply to the formula 2 square and then 3 4 5 up to 6 dot dot dot, okay, at 3 square. So 2 into 2 4, 3 into 3 9. So LCM we are taking 36. The 5 inga 9 inga 4 minus panna 5 by 36 or this is a Balmer series. Okay, the same like only for that next Paschen series. Paschen series also what happened? So the electron, fourth n equivalent to 4. So the fifth n equivalent to 3. N equivalent to 3. Fourth electron and fourth cell, sixth cell, seventh cell, all the cells electrons moving to the third shells. Okay, so now that taking to the n equivalent to 3, m equivalent to 4. So now you are applying to the formula. So the same like for that same like the phi fund also. So n equivalent to 5 means the fifth electron, the fifth cell tavira other all the shells electrons moving to that fifth shells. Okay, so now we are taking to the 5 and m equivalent 6 7 8. So now we are calculate this one. This is the different spectral series. Okay, wow. So next you see that the limitation of the Bohr atom model. So now you see that Bohr atom model is a valid only for hydrogen atom or hydrogen like atoms but not for the complex atom. It is here like the atom but not a complex. When the spectral lines are the closely examined, individual lines of the hydrogen spectrum are accompanied by the number of finite lines. These are often called the fine structure. This is not explained by the Bohr atom model. So it is not explained the fine structure. Bohr atom model falls to the explain the intensity variation, the spectral lines. The false. So we cannot able to explain the failures to Bohr atom explain to the intensity variation in the spectral lines. It is a failed only. It is not explained properly. So that distribution of the electron in the atom is not completely explained by the Bohr atom model. Okay, I understood, ma? Any doubt you will ask to me. Okay, thank you children.